Thank you very much.
Hello, everyone. We're really excited to be taking part in this. And we would also like to thank you all for being here, since, for the next 45 minutes or so, you will have to bear with us. This is Oikonomidou.
And this is Alexandros Sarakenidis.
Yeah, as was said earlier, we both work as full-stack software developers for AMD Telecom on Project Rudy. Rudy was launched by AMD Telecom in 2016 as a web and API platform to provide communication as a service solutions.
Now, Rudy's main services are messaging, voice verification, and as you can see on the slide, some companies that work with us. Okay. Now, one big part of our web application project, of our stack, is our web application project, which is, of course, front-end related, and our framework of choice is AngularJS. Of course, we're not AngularJS experts, but having been involved in an AngularJS project, we have come to, and trying to keep it up to date, we have come to realize that there are some best practices that one can follow in order to benefit their project and also make it more upgradable.
By the way, guys, when we say AngularJS, we actually refer to Angular version 1.plus, and by Angular we refer to Angular version 2 or higher. So, how many of you have ever worked with AngularJS? Nice, nice. How about Angular then? Cool, cool.
Okay. Our main topics are going to be package management, module management, and bundling. We're also going to talk about TypeScript, which is the scripting language we use in our web application. Also, AngularJS controller as syntax, and of course, components in AngularJS. Now, later on, we will explain what each one of them is and some of the most important benefits. So now Alex is going to start with our first topic.
Thank you. When creating or maintaining an AngularJS application or any large-scale web JavaScript project, one has to think of many things. Things like managing dependencies, internal and external, selecting the right tools for the job, building the project, stuff like that. So the next section concerns this kind of issues and some possible solutions. So let's start with how we load third-party libraries into our project. There's always been script-like imports, right? So what's wrong with that? Well, this seems fine, yeah, but a few months of development later, and it could end up looking like this. And this seems bad, chaotic, you name it. But it creates even more problems. Problems like the need to load the libraries, the scripts in the correct order. For example, if we have a dependency A and it needs a dependency X to function, we have to make sure that we load dependency X first, right? So, problems. We've got a lot of dependencies to manage in one file, or in other HTML files as well. Order does matter. And we've got a ton of sync or HTTP calls in our hands, which is not a good thing either. So what can you do? What can we do? We can use a package manager. Well, package managers are tools that help us manage our dependencies. They're also capable of so much more, but that's their primary use. What they offer are things like structured dependency management, and of course, even if we can manually use them and download all of our dependencies one by one, the recommended way of using them is through a configuration file. So we have one central configuration file, and all of our dependencies are there. And it's much easier than having to search for script-like imports inside our HTML code. Then again, they also offer easy installation and upgradability. So once our configuration file is ready, if we're, let's say, to use the npm package manager, all we have to do is type npm install and our dependencies which are downloading. In addition, the order doesn't matter. And about this, as far as the package managers are concerned, order doesn't matter. They just download our dependencies to our project locally in our computer. But how we load them into our application, that's another story. And that's where bundlers come step into. And we'll talk about bundlers later. But they also make our dependency configuration much more flexible since, well, for example, we can differentiate between normal and development dependencies. Yeah, so we're going to use a package manager, but which one? There's so many out there, NPM, Yearn, Bower. So which one should we use? There's not a correct answer to that. Whatever works for you guys. We use NPM, and we use NPM because of its huge registry of packages. It's got all the dependencies that we need. It's also fairly easy to use. It's also pretty much the default package manager for Node.js that we use, even though Yearn is getting very popular nowadays, but still using NPM's registry. And last but not least, it's the Angular CLI, which is the tool that helps us with Angular applications. Depends on features and functionality that are available as from libraries that are available as NPM packages. So, well, it pays off to be a little bit familiar with that. Now, the thing is, as we said, we chose NPM, but you might choose to use something else. But whatever you guys actually choose, we strongly recommend using just one, because it makes things simpler, if possible, of course. But why? Well, in the beginning of our project, we're using 3 different package managers. And even though it wasn't the worst thing in the world, we had to deal with multiple configurations for our dependencies. So once we realized that all of our dependencies exist in the NPM registry, we just chose to use NPM only. And now, coming up next, module management by Vaso.
Okay. Now, module management. Even if you're not using AngularJS at all at your project, chances are that you have broken down your application into multiple JavaScript files. So you've ended up with a large number of relatively small files. Now, JavaScript began as a language for building small-scale websites. In time, though, websites are becoming web applications and code bases, and functionality is growing to become larger. So now we're facing another problem, module management. Now, by module, we don't actually mean an AngularJS module, but any piece of code that can be used as a dependency from other JavaScript files. So, how does one JavaScript file get to know and use another? We could, again, make use of the script tag imports, but as we have explained earlier, this isn't always a very good idea. In addition, one of the most important reasons for using modules is JavaScript's global namespace, which can become easily polluted. So in order to solve these problems, we use a module management system. Now, using a module management system actually gives you a lot of benefits, such as application code organization. It lets you divide up the functionality of your application into multiple pieces, distinct pieces of code. Code reusability. You can use the same code module, let's say, wherever the same functionality is needed. Code encapsulation. Modules actually keep their implementation private and expose a public API. And of course, code maintainability. It's easier to update a single module when that module is decoupled from other pieces of your code. Okay. Now, before we go into module management systems, we need to talk about ECMAScript, or commonly known as ES. This part gets a little bit confusing, that's why we need to explain it a bit. What is ES? ES is actually a standard used for scripting languages, and JavaScript is an implementation of it. So a lot of things concerning JavaScript are actually specified by ES. There are a lot of ES specifications, as you can see, ES5, ES6, ES7, and so on. But not all of them are widely adopted by JavaScript environments yet. ES5 is the first that is widely adopted, but it has a problem. It doesn't specify a module management system. ES6, on the other hand, was the first to specify a module management system. So, in order to solve this problem, other custom specifications were introduced, like CommonJS, AMD, and others. Still, those custom specifications actually are supported by specific runtime environments, like Node.js, but not by browsers. We, in our project, use the CommonJS system because we use Node.js that implements it, and of course, it's fairly easy to use. Okay, now let's see an example of an ES module management. In this example, we suppose that we're using the Node.js runtime environment. So as you can see, we have a parse helper file, JavaScript file, that has a function called normalize that does something. And let's suppose that we want to use this functionality inside our app.js file. In order to do this, we need to somehow let our app.js know about parse helper. This can be done in two steps. First, we need to export our parse helper file as a module, and then we have to import that module into our app.js file. In Node.js, in order to export our parse helper, we use the module.exports object, which is actually used for assigning functions or anything else we like to expose to other JavaScript files. Now, in order to import that module into our app.js file, as you can see, we use the require statement, passing it as a variable the relative path of our parse helper file. We also assign it to a variable in order to use its functionality later on. So, that's it with module management. Now Alex is going to talk to you about module bundling.
So yeah, well, we can split our application code in multiple bundles, files, and Node.js or whatever we use might understand it. But what about browsers? What browsers supporting up to ES5 don't have a clue about it. So as far as they're concerned, all the application code has to be in a single file, or as far as multiple files are concerned, they have to be imported separately. So this is where module bundlers come into play, or module loaders. Module bundlers are tools that can combine separate modules, files, into one or more bundles. So if we were to combine all of our application code, all of our modules into one file, then our browser would only have to import just one bundle. Of course, we might want to split it into more. It depends on the situation. So, of course, to do that correctly, module bundlers traverse our dependency graph, and they determine who needs what. Cool, right? Most of them also support extra goodies, extra functionality, which is nice. And our pick for bundler is Webpack. And we use Webpack for a couple of reasons, like it supports the CommonJS system. For the record, it also supports AMD. It's relatively simple to use.
We have thoughts about that.
Second thoughts about that. The documentation is getting better and better. It also supports tree shaking, watch mode, which is great for development since it can actually auto-detect code changes and recompile. It also has a big community, and if configured so, it can handle the entire build process for us. which is a nice bonus because we might not have to use any other tool like a task runner for it. In the beginning, we were using the Grunt task runner for our build configuration as well. So some work was done by Webpack, some work was done by Grunt, not so clean. So once we moved all of our build configuration to Webpack, it made our configuration a little bit cleaner. So this is pretty much all about module bundlers, and on to more interesting things. TypeScript. Well, what's TypeScript? TypeScript is a typed superset of JavaScript that compiles into plain JavaScript. Okay, and what does it do? Well, for starters, it supports types. Type checking and compiler errors are a thing now. It's also feature-centric, supports new ES features, like ES6 module management system, but also let variable declarations, fat arrows, and others. In addition, it supports classes, interfaces, and OOP features. One might say it's the scripting language for Java developers. But also valid JavaScript is valid TypeScript too, which essentially means that we can take advantage of any JavaScript library. And last, it's recommended for Angular applications, since Angular was actually written in TypeScript. Okay, cool. So let's see a simple example. Suppose we have this little function called add numbers, and its purpose is to accept two parameters, two numbers, and return their summary. Notice how easy it is to declare types for our method parameters, our functions return a result. About the result variable, we just have to type a colon and the type next to it. And the snippet on the bottom would be its JavaScript equivalent, of course. So having added types, let's try to do something weird. Let's try to use our add numbers function by passing it a string and a number instead of two strings, instead of two numbers. What will the TypeScript compiler do? Well, as we can see, it will nag about it, won't like it. And our IDE will probably let us know, since there's great support for TypeScript from IDEs. And things like this can be avoided when using TypeScript. On the other hand, with just plain JavaScript, of course, as expected, no problem would be reported, and the result would be the concatenation of our string and our number string. And now Vaso will now continue with some AS6 features TypeScript supports.
Okay, we mentioned earlier that TypeScript is actually future-centric. Okay, sorry about that. So it supports a lot of ES6 features already, like module management and others. Here we can see a fairly simple example. You can see in the first snippet the helper.ts file, which contains a function, our beloved add numbers function. In order to export this function, you use the export function add numbers syntax. See how easy it is. And in order to import that function into, let's suppose, our app.ts file, you use the import syntax, import star as helper from /helper. Isn't that simpler than what we did with CommonJS and ES5? I think it is. So now, if we were to execute this code into a runtime environment that doesn't support ES6 module management, this code wouldn't work. But TypeScript compiler deals with this problem by transpiling it to a target specification for us. Okay. Now, we also mentioned that TypeScript supports some object-oriented programming features. Those of you that come from an object-oriented programming background, you're going to love this feature. Here we can see an example of classes and interfaces. It's fairly simple. You have a class called developer that implements an interface called coffee consumer. Now, keep in mind, though, that interfaces in TypeScript doesn't always work as one might expect. They're mostly used for consistency and type safety. But nevertheless, using interfaces in your application, it makes it more flexible and more loosely coupled. Okay, if we run this code and transpile it into an ES5 specification, we will get something like this. As you can see, the interface is gone, since there's no notion of an interface in ES5 specification, and our class has been transpiled into a function. Now, other benefits that the use of TypeScript gives to us is that you can migrate your JavaScript code to TypeScript step by step, since actually TypeScript is a superset of JavaScript, and any valid JavaScript code is valid TypeScript code. The compiler output is readable and debuggable since it's JavaScript. Many TypeScript features will be available in future versions of JavaScript. You also don't need a special runtime environment since TypeScript is compiled to JavaScript, as long as JavaScript is supported by your runtime environment. And the most important one is that you're able to compile to many ES specifications. Okay, now Alex is going to talk to you about the controller as syntax.
Yeah. Okay, those were some general purpose best practices that happen to aid us one way or another in an AngularJS app. But now let's talk AngularJS specific. Suppose we have this little stupid app, AngularJS app, and we have just a controller that just manipulates some data and it's displayed. So this is how it would be implemented most times. We've got three snippets. The first one is our controller, the second one is our HTML code, and on the third one is the module creation and the controller registration. So let's start with the second one, the HTML code. What we need to notice here is that we're using the ng controller directive to bind our controller to the DOM. And when we do like this, what happens is basically AngularJS will instantiate our controller instance, and a new child's code will be created, and it will be available. It will be available as an injectable parameter to our controller's constructor. So if we now take a look at the first snippet, we can see that we've got a scope parameter inside the constructor, and what this means is that if we want to manipulate some data, we have to do it on the scope. So if we were to let's say set property name to the value zone, we'd have to do it this way, this.scope.name and assign the value zone. And then to display it, we would have to, in our HTML code, use the property name inside curly brackets. And yes, this works fine, but I don't know, why should we have to deal with that scope? Isn't it a little dirty? Well, it is, and there's a better way to do this, and the better way is using the controller as syntax, and it looks like this. So let's see what changed. Again, in our second snippet, we're using the ng controller again, but this time, instead of just welcome controller, we're using welcome controller as welcome. So essentially what happens here is that our controller instance will be assigned to a property on the scope, and we declare that name. In our case, it's welcome. We set it, and what this means is that we can now work with controller properties. So again, in our first snippet, our controller, we've got a property name, controller property, and we initialize it again inside our constructor. Much easier, of course, there's no scope injection this time. And to show this, to display this in our HTML, we'd have to use welcome.name inside curly brackets. And this looks better, I think. And so what are the benefits apart from that? Yeah, cleaner code, as we said. it also introduces scope soup. Scope soup is this thing with AngularJS that everything has to do with scope, and when we can avoid it, well, it's considered a good practice. It's also more Angular friendly. In addition, in case we have multiple controllers with the same property names, we can easily identify which property belongs to which controller if we're using this practice. And last but not least, this might also help us avoid some problems that are caused by JavaScript's prototypal inheritance, but that's beyond the scope for our session right now. And now Vaso will continue with components in AngularJS.
Another actually practice which is super popular and we find it very useful is the use of components in AngularJS. Okay, but what is a component in AngularJS? Actually, a component is a type of directive that has an isolated scope and a restrict option of fee, meaning element. It also has its own controller and template, as you can see in the snippet above. In AngularJS, it was introduced, a function was introduced, a helper one, .component, which actually makes it easier to register components in Angular. And also, the use of it helps you to eliminate boilerplate code. Now, some of the key aspects of using components in AngularJS is that they use one-way data flow, meaning that only the component that owns the data should modify it. This makes it easy to reason about what data is changed and when. They offer you potentially better performance because AngularJS has less changes to watch for. They provide you with well-defined lifecycle hooks. Each component implements a number of lifecycle hooks, which are actually methods that are called at a certain point in the life of a component. Such methods are on init, on changes, on destroy, and others. They're also Angular friendly, meaning that they are closer to the component-based architecture used in Angular. So if you want to migrate your application in Angular, it will help a lot. Okay. Now, the use of components and component-based architecture in our project was a really big asset. And you might ask me why. Well, imagine this. You have an element directive that has a two-way data binding on a property called user. That directive has a child element directive that has the same two-way data binding on user property again. And then you have a third one. Okay, so you've ended up having a property that can be changed by any three of the directives. Isn't that a little bit confusing? I mean, who changes what and when? This kind of data flow is actually really hard to understand, and of course it's really hard to control. So components and one-way data flow is the way to go, since only the component that owns the data should modify it. But enough with theory. Now Alex is going to show you an example of a component in AngularJS.
Yep. So yeah, let's see a simplified version of a component in AngularJS. Let's say that we're going to need a component, a simple one, and that it should have the following functionality. It should be able to receive an array of languages and display them as an input binding. And it should be able to allow us to type a new language and then notify its parent through an output binding. Let's start with our component. Here's the class. Of course, what our component needs to function is a controller and a template, but in our case, we will need also the input and output options as bindings. So let's start with that. inside the constructor. As input, we've got languages with one-way binding, which will, of course, hold our languages. And as output, we have on language addition, which will function as a callback to component events. Of course, this is just an expression that will be evaluated in the parent, but let's just think of it as a callback function. And then we have we set our controller. We're also using controller as, and then we have our templates URL. So let's see the controller and the HTML code. About the controller, at first glance, we can see that we've got 3 properties. Languages, which is a string array, and it will hold our languages. It's our input binding. Then we've got on language addition, which is a function, that callback function we talked about, the output. And then we have the new language string property, which will actually accommodate a potentially new language. Then we have our constructor, which does fairly nothing. And now let's think a little. Suppose that we wanted to initialize some data. Yeah, we could have done it in the constructor, but there's a better way to do it. And that better way is using the onInit function. Remember all those nice, well-defined lifecycle hooks Vasiliki told you about? This is one of them. And what makes us want to choose this over the constructor is that this is more testable, but it's also safer. It's also safer because we can be sure that our bindings have been initialized. Okay, then we have send language at callback function, but we'll get to this later. Let's check our HTML code instead. So we have this parent div element, yeah, whatever. And then we have 2 inner divs. The first one, it's got a heading, yeah. And then we've got a label with the ngRepeat directive, which will actually iterate through our languages and display them. And about the second one, we've got basically a text box with the ng model directive on new language, which essentially means that whatever we type into that text box will be passed into that new language property and vice versa. And last, we've got a button which, when clicked, will trigger the send language at callback function. Now, let's imagine that we type a new language in the text box and we click that button. Let's see what happens. Let's go back to our first snippet and check our send language at callback function. What this will do is it will trigger the onLanguage addition function, our callback function, and it will pass it an object with an event property which will hold our new language. This will basically notify the parent about that new language, but then it's the parent's responsibility to do whatever it wants with it. It's out of our hands now. So yeah, about that $event property name, we didn't have to use that, but we use that because we like to think this functionality as an event, but this also emulates Angular output functionality. Cool. So yeah, having said all this, let's see how easy it would be to convert this AngularJS component example into its Angular 5 equivalent, and Vasiliki will show you.
So, now if you can see on the first snippet we have on the slide, the component and controller definitions have actually been combined in one file, the component. The component is now declared using a decorator, as you can see on top of the class. Also, in order to declare our bindings, we use decorators as well, input and output on top of the properties. Our languages property has remained the same. The onLanguage addition property is not a function anymore, but it is an event emitter object, but nevertheless it's used for the same purpose. The onlyNeed function has been renamed to ng-onlyNeed, and as you can see, the component now implements the onlyNeed interface. And our send language add callback function now uses the event emitter object to emit an event and notify the component's parent about the new language property. And now about our second snippet, the HTML code, as you can see. Not much changed here. Basically, what has changed are the selectors for the directives used. And if you can notice, we now refer to our language property directly, since AngularJS knows that it belongs to our components property. So that's about it. To sum it up, we actually recommend that you use package and module management. You use only one package manager if possible. You should organize your code. You should avoid using multiple configuration files. You should also use TypeScript because you will benefit from types. You will tap into ES6 object-oriented programming features and be one step ahead. You should also use controller as syntax because it will help you to produce cleaner code and avoid scope soup. You should also use components when appropriate, because they will help you to achieve easier to understand flow. You will tap into lifecycle hooks and control your data flow. It will enhance the performance of your application. And, of course, it will help you to a potential migration in Angular. That's it.
So, thank you guys for having us. We'll be glad to answer any questions that you'll have, if we can, of course. So, any questions? Oh, okay.
I want to ask you, how do you import an existing project that uses classes? Suppose you have a factorial.
We have a
class that produces
okay.
classes in JavaScript. You have another class, say a tree class, that builds a tree.
Yeah.
Another superclass that builds a more elaborated tree.
Okay.
Suppose this is 2,000-3,000 lines JavaScript. Now, what will you do to
actually import it?
Convert it to Angular project?
If it's just JavaScript, it's JavaScript, right?
Yes.
There's no problem. If we can just use it inside our TypeScript files, we'll just have to manually declare it and set it as.
It is TypeScript, of course.
And that's all we have to do actually. Since we use it, Webpack would actually bundle that inside the final bundle.
Will be any intricacies with the visual part, because JavaScript actually fiddles DOM objects. So the Angular now, how will handle this situation? It will also have to somehow leave the control to the existing project, or take the control and start acting on DOM nodes.
Okay.
So I think it's, I don't know, what will you do in such situation?
Well, maybe I didn't understand the question correctly.
Suppose if you have seen Firebug, it was a tool, or the inspector tool at the Mozilla development tools. Suppose now you have Firebug built on with JavaScript, And what it does, it creates trees that actually modify parts of the DOM tree in some other area of the page. You have a visual representation of the tree, and you have the actual nodes that are represented by this tree. Exactly what the inspector does. You see a representation of your web page as a tree, as a visual tree. Now, if you have such a complex project and you want to somehow convert it to Angular, you have intricacies in many areas like events, DOM handling, classes, JavaScript classes.
Okay.
I suppose you'll start from classes and convert them to TypeScript. It's very easy. But the event handling is, I don't know, what will you do in Angular?
Well, if I understand correctly, you're asking what we would do with all those things that actually manipulate DOM?
Later on the road,
yeah.
yes.
So instead of components, which actually have a restrict option E, there are, of course, directives, we could use another kind of directive, the one with a restrict option A, and we'd have access to the link function and other things like that. Which can do.
Will you leave control to the existing system and maybe wrap it in Angular? Because I don't think it's easy to rewrite, as some people say in the internet, because there is a tension to rewrite everything in Angular. But there are many tools out there or projects that do many things to the interface, and it's quite difficult to rewrite. It's difficult to rewrite a tree code that does such complicated things.
Okay, truth is, I don't really know what would be the best course if we. Yeah, of course it would be.
By its own.
It would be hard to just boom and go Angular all the way. If there is some step-by-step procedure, of course that would be the best way, because I will know that things like that, like all at once.
Taking part of the project will go to Angular way, and maybe some parts will remain JavaScript, I suppose.
Yeah. So, any more questions? Oh, okay. If you have any questions later, you could find us outside or something, and we'll be glad to answer them. Thank you again for having us.